Hey everyone, let's jump right into this explainer. Today, we're decoding exactly how the processed foods industry measures its massive packaging footprint. If you've ever stared at a food label and wondered if those bold sustainability claims are actually legit, well, there's a very strict science behind those numbers. We're going to look closely at the SASB standards to see exactly how companies calculate the total weight of their packaging and how they figure out the exact percentages made from recycled, renewable, recyclable, or compostable materials.
To really understand the math behind these claims, we're going to build the equation step by step. First, the packaging life cycle. Second, calculating the total baseline weight. Third, evaluating sustainable inputs. Fourth, mapping end-of-life metrics. And finally, real-world strategies for reduction. Let's get started.
All right, part one, the packaging life cycle, setting the stage.
You know, for the processed foods industry, packaging is a massive business expense, and it leaves a tremendous environmental footprint. Every single step, from the initial design phase to transportation, right down to disposal, presents a huge challenge. On top of that, companies are facing increasingly strict legislation about what materials they can use and how they have to handle the waste. That's exactly why the industry relies on rigorous frameworks like SASB metric FBPF 410A.1. It demands quantitative tracking of weight, inputs, and outputs. It's not about vague green promises. It's about hard, verifiable data.
Moving on to part two, calculating total weight, establishing the baseline.
Okay, so before we can even think about calculating those impressive sustainability percentages, we have to nail down our baseline total weight. This is our denominator. Without a highly accurate baseline, the rest of the math simply falls apart. The crucial point here is knowing exactly what counts in our equation and what gets left out. We include primary and secondary packaging, the actual materials that hold the food and sit on the store shelf. But we completely exclude tertiary packaging. That means those bulk transport pallets and the endless layers of distribution shrink wrap, they don't go into this specific baseline calculation.
Let's get crystal clear on what we're actually weighing here. Primary packaging is defined as the material designed to come into direct contact with the food itself. Think of the plastic bag holding your cereal. Then you've got secondary packaging, which is designed to contain one or more of those primary packages. That's the cardboard cereal box. That right there is our exact footprint boundary.
So once a company gathers up all that primary and secondary packaging they purchased over the reporting year, they weigh it all together as a single baseline number. And the required unit of measure for this framework? Metric tons. This grand total is absolutely crucial because it becomes the denominator for every single sustainability equation we're about to look at.
Which brings us to part three, sustainable packaging inputs, what it's made of.
Now that we've got our total weight denominator locked in, let's talk about the numerator. What exactly went into making this packaging before it ever reached the consumer? We compartmentalize sustainable inputs into two highly specific buckets, recycled materials and renewable materials. Under SASB standards, recycled content can only come from pre-consumer or post-consumer recovered waste. Renewable materials? They have to be composed of biomass from a living source. We're talking trees, crops, algae, or even manure. But the catch is, it has to replenish at a rate equal to or greater than its depletion, so fossilized materials or peat are completely off the table.
And let me tell you, the rules here are incredibly strict to shut down greenwashing. Using precise ISO 14021 definitions, pre-consumer material has to be genuinely diverted from the waste stream during the manufacturing process. You cannot just sweep up regular scrap or rework that naturally gets ground up and cycle back into the same machine. And post-consumer material actually has to reach the end user, like a household or a commercial facility, before it gets recovered.
So, here's our first completed equation. A company simply divides the combined weight of those strictly defined recycled and renewable materials by our baseline total weight. If a package is a mix of virgin and recycled parts, the company literally has to calculate and split the weight accordingly. The resulting percentage proves exactly how sustainable their sourcing really is.
All right, part four, end-of-life packaging metrics, where it goes.
So we know exactly what the package is made of, but the life cycle doesn't end there, right? What happens when you're actually done with it? Looking at our output metrics, a package only counts as recyclable if real-world programs actually exist to divert it from the waste stream, collect it, process it, and turn it back into raw materials. You can't just call it recyclable in theory because of its chemical makeup. The actual physical recycling infrastructure has to be available to handle it.
It's the same deal for reusable packaging. A package is only considered reusable if it's explicitly designed to accomplish a specific number of trips or rotations for its exact original purpose. And, crucially, a company can only make this claim if they have a legitimate program in place to actually collect and reuse the packaging, or if facilities exist so the purchaser can reuse it.
Finally, we have compostable materials. For this output, the materials must biologically break down into CO2, water, inorganic compounds, and biomass. And they have to degrade at a rate consistent with other known compostable materials, without leaving absolutely any visible or toxic residue behind. It adheres strictly to standards like ASTM D6400 for plastics.
Now we complete our output equation. You just take the total weight of these three sustainable outputs, the recyclable, reusable, or compostable materials, and divide them by our initial baseline weight in metric tons. This is a real game changer because it forces companies to take full mathematical responsibility for the end-of-life reality of the trash they push into the market.
And finally, Part 5, Strategies for Reduction, the Payoff. So why did they go through all this rigorous math in the first place? Well, by tracking these metrics, companies can execute highly targeted strategies. They might optimize packaging weight to keep food safe using ISO 1862 standards, or run comprehensive life cycle assessments to maximize the packaging's efficiency. They might even adopt alternative compostable materials where it makes sense. And here's the kicker. These aren't just environmental wins. Lighter, more efficient packaging directly slashes their massive transportation and material costs.
Now that you know the detailed anatomy of these equations, how's this data going to change your perspective next time you walk down a grocery store aisle? When you pick up a box, a bag, or a bottle, just remember the precise, rigorous math required to actually measure its footprint. Next time you buy processed food, ask yourself how much of this specific package's total weight was truly accounted for in the company's sustainability math. Thanks for joining me for this explainer. I really hope it gave you a fresh perspective, and keep asking the right questions.